This is a really quick review for Half-Life for pre-AP. Just 3 quick problems. Number 1 says the half-life of a radioactive atom is 12.4 hours. How much of a 750 gram sample is left after 62 hours? So I've got 2 times here, and I have a mass. So I need to find out how much of this is left over after this decays, after 62 hours. So I need to find out how many times it's going to decay. How many times will it be divided by 2 or halved in that period of time? So I go 62 hours divided by the half-life, which is 12.4 hours. 62 divided by 12.4 is 5. So this thing decays 5 times. 5 half-lives go by. Okay, how much of the 750 gram sample is left over after 5 half-lives? So we're going to divide 750 by 2 5 times. So there's 750 divided by 2 is 375. Okay, that was 1 half-life. 375 divided by 2, 187.5. That's my, oh, golly, I messed up there for you. Divided by 2 is 187.5. Okay, that's my second half-life. So I'm going to divide that by 2. 93.75 after 3 half-lives. Okay, still got to go to 5 half-lives, so I've got to divide it by 2 a couple more times. By 2 is 46.875. That's my 4th half-life. Divide that thing by 2 one last time. Put it right there. 23.4375 grams. That was my 5th half-life there. So after 5 half-lives, 23.4375 grams remains. That's what my question was. How much of this sample is left after 62 hours? So in order to write this with a correct number of sig figs, that has 3, that has 2, and that has 2. So my final answer has to be rounded to 2 sig figs. That 4 does not cause that 3 to round up, so my final answer, 23 grams. Okay, next one. Number 15, I'm sorry, number 2. I was looking at the 15. Oxygen 15 is used as a radioactive tracer in medical imaging. Oh, there's the bell. It has a half-life of 2 minutes. Pretty quick. If the initial concentration of oxygen 15 is 16 millimoles, how long will it take for it to decay to 1 millimole? So I need to find out how many half-lives occur from 16 to 1. That's my concentration. It says that 1 half-life is 2 minutes. Okay, so I need to figure out how many half-lives go by. So 16 divided by 2 is 8. There's 1 half-life. Divide that by 2, that's 4, 2 half-lives. Divide by 2 is 2, that's 3 half-lives. Divide that by 2, and look, I finally got to there. There's 4 half-lives. So 4 half-lives go by from 16 millimoles to 1 millimole. So what I do is I take the 2 minutes. I know that 1 half-life is 2 minutes, but it went 4 half-lives. So 2 minutes times 4 half-lives gives me 8 minutes. That's how long it will take for it to decay. Number 3, if 20 grams of a radioactive isotope are present at 1 o'clock and 5 grams remains at 2 o'clock, what's the half-life? Alright, so I start with 20 grams and I end up with 5 grams. How long did it take? It took me 60 minutes. You could say 1 hour. It doesn't really matter. But 60 minutes to go from 1 o'clock to 2 o'clock. Okay, so that's the total amount of time. That's the total time. Because I want to know what is the half-life of it. Okay, that's the total. What's the half-life? What's one half-life? So I have to figure out how many times 20 decays in half to get to 5. So 20 divided by 5 is 10. There's one half-life. 10 divided by, did I say 5? Really? Really? Wow, rookie mistake, man. Alright, 20 divided by 2 is 10. There's one half-life. 10 divided by 2 is 5. So it takes 2 half-lives in order for this radioactive isotope to decay from 20 grams to 5 grams. Okay, that thing occurs in 60 minutes. Alright, so in order to find out how much is one half-life, 60 minutes was the total time, 60 minutes divided by the 2 half-lives. So one half-life, 30 minutes. Okay, there you go. Don't stress too much, and good luck.